This is the 3.3 lesson, but I'm going to start by talking about two homework problems from 3.2 that I didn't answer completely. First, number 2. There are two supplementary angles in this diagram, and I named one of them angle CBH, which is right here, which is a 70-degree angle. So the other angle we are looking for must be a 110-degree angle, because supplementary angles have to add up to 180. There is no angle identified as 110 degrees in this picture, but doesn't this angle right here have to be 110? Because aren't we supposed to assume that that's a perfectly straight line? And therefore that these two angles add up to 180 degrees. So 180 minus 70 is 110. In fact, and so the finish to this answer is angle CBA, or you could call it angle ABC. That wouldn't matter. In fact, if I hadn't put that angle measure in there at all, if I had left that blank, you should still give this answer, because no matter what these two angle sizes are individually, they would have to add up to 180 degrees, because that is a perfectly straight line. The other problem I didn't answer was number 18 here. I said we'd talk about this in class. I asked for the measure of angle ABC, this angle over here, not either one of these angles, which is next to the 42 degrees. Well, we can determine the measure of this angle here, because since this is a straight line, if we subtract this 42 degrees from 180, we'll get the measure of this angle here, 138. And then look, that's a straight line also. So now we can subtract that 138 from 180 to find the measure of this angle here, which is 42 degrees. Happens to be exactly the same as this angle over here. And the question that today's lesson is going to answer is that just coincidence, or would that kind of thing happen all the time? So let's get into the lesson today. Here's the notes. If you haven't printed them out, and you can, print them out. If you can, stop the video right now and try all the problems on this first page only. Okay, stop the video, try them now. All right, if you had a chance to try these problems, let's go over them. The measure of angle ABC, that's point B in there. All right, well, there's a straight line. 180 minus 45 would be 135 degrees. That would be the answer to the measure of angle ABC. Measure of angle DBC, well, you might be guessing from that homework problem that we just went over that this is also 45 degrees. But if you guess that, I wonder why. Because if your reason is, well, it looks like it's the same, that is not a good enough reason. Okay? I need convincing evidence that this angle must in fact be 45 degrees. And I don't know that you're going to be able to give me that convincing evidence if you don't do this. See this answer we got to angle ABC? Put that angle measure in the diagram. You're going to hear me say this a lot. The more complicated the diagrams get, and they're going to get complicated in a hurry, much more complicated than the ones you see in this homework. Anytime you find the measure of an angle, add that angle measure to the diagram if you're not done working through the questions about that diagram. And we are not done here. We haven't answered this question. Add that angle measure to the diagram. See, because now I can explain to you, or you could explain to me, if I'm asking you to do that on a quiz, why this angle will in fact have to be 45 degrees. Because look, there's another straight line, right? So that total rotation there is 180 degrees, and there's 135 of that 180. So subtract that 135 from that total of 180, and we get 45 degrees. So this angle does in fact turn out to be the same as that one. And here's the work that demonstrates it. Okay? Same identical thing going on over here. If we're looking for ABC, here's a straight line. Subtract that 60 from 180, and we get 120. But you can't really explain to me how you get an answer for this angle here if you don't add that 120 to the picture. Now we've got another straight line from A to D. So that's 180 degrees of rotation minus that 120 is equal to 60 degrees. Okay, so these are exactly like homework problem number 18 that we were just talking about 3 minutes ago. Okay, but now when you get down to problems 3 and 4, the diagrams are different in an important way. It is still possible to find the measure of angle ABC in this diagram because NC is a perfectly straight line. So 180 minus that 40 is equal to 140. Okay. Now, is it possible to find the measure of angle DBC? Well, let's add this 140 to the diagram. Can we find the measure of angle DBC? Is it the same as this 40 degrees? Hey, I got a question for you. Does it even look like it's the same as this? I hope to you this angle looks bigger than that one. All right. Although, even though it does look bigger, we can't really know that it's bigger. But here's what I do know. This is not a straight line. I mean, for sure, that does not look like a straight line, and for sure, we should not assume that it is a straight line. Therefore, from here around to there is not 180 degrees. I have no idea how much that is. I have no way of finding this angle measure. This cannot be determined, or there is no way to know. Might be another way of saying that. Kind of looks a lot like Keeping Up with the Kardashians, doesn't it? There's just a U missing in there. But, all right, no way to know in this case. And similar thing going on over here. ABC, we can find that angle because there's a straight line. 180 minus 150 is equal to 30. Let's put that 30 in the picture. Can we find the measure of angle DBC? This one here. Hey, now wait. Doesn't that angle appear to be the same size as this 30-degree angle here? Sure it does. But so what? Okay? It looks the same, not good enough in this class. There is no way to know. Okay? I'm writing the whole word to there. No way to know. Or KWTK. Or cannot be determined. Okay? What's different between these two pictures and these two pictures? In these two pictures, all you have is two lines. That's it. Two straight lines intersecting. Two straight lines intersecting. In these diagrams, you have more than two. Here's one, here's a second, and here's a third different line. Right? Same with there. One line, two lines, three different lines. So the general lesson from these four problems here is when you have two straight lines intersecting each other, this angle over here and this angle over there, the angles that are not right next to each other, okay, but are kind of across from each other, they will always be the same size. Okay, it's not just coincidence that it happened in this problem and in this problem. A little bit of algebra can show us that it's guaranteed these two angles will always be congruent to each other. So let me show you that little bit of algebra. Okay, let's call this angle C. Since this is a straight line, don't A plus C have to add up to 180? And since this is a straight line, don't B plus C have to add up to 180? Okay. Well, now, what happens if you subtract C from both sides of this equation? You would get A is equal to 180 minus C, right? And what happens if you subtract C from both sides of this equation? You would get B is equal to 180 minus C. See, there's proof using just a little bit of very simple algebra that A and B are guaranteed to be the same value every time when the diagram looks something like this. Okay. Now we have a name for these kinds of angles that are across from each other, not next to each other, but kind of across from each other, sort of like diagonally across. Imagine that these are 4 desks all seated in a group, and you're sitting here and somebody else is sitting there. You're not sitting next to that person. You're sitting next to this person and that person. You're kind of diagonally across from that person, right? We have a name for those kinds of angles. They're called vertical angles. And they are guaranteed to always be congruent to each other. Write this down. Are you writing this down? This is the lesson for today in a very concise statement. But you got to know what the phrase vertical angles means. And that could be a little confusing because we already have a meaning for the word vertical. It means running up and down, like the y-axis runs vertically. Okay? But this word in this phrase has nothing to do with running up or down. Nothing to do with it. It means 2 angles that are like diagonally across from each other when you have 2 intersecting lines. Okay? That's a lot of words to explain the meaning of the word vertical in this phrase. Okay? By the way, C and D are also vertical angles in this picture, and they are also congruent to each other, guaranteed. Okay. Now, I remind you that the double arc here in angle C doesn't tell us anything about how angle C compares to angle A in size. It doesn't mean that angle C is twice as the number of degrees as angle A. It doesn't even mean that it's larger than angle A. I mean, it looks larger, it looks obtuse, this one looks acute, but again, looks are almost never good enough for us, okay? So know what vertical angles look like, be able to recognize them in a picture, know that they are congruent. From now on, anytime you run into a diagram that has 2 intersecting lines, and I've given you the measure of one angle, my expectation is that you are going to instantly recognize that, hey, that angle's got to be the same as this one. You do not have to work your way towards this angle measure in order to get to this angle measure. Okay, from now on, that's unnecessary work. If you see this as 50 degrees, I expect you're going to be able to immediately write down that that is also 50 degrees. And then, of course, subtracting that 50 from 180 immediately gets you the measure of those 2 angles there. All right? All right, half of the homework problems involve that kind of idea, vertical angles. Let's go over to the second page of the notes and do something completely different. More work with complementary and supplementary angles. In a moment, I'm going to stop talking. I want you to stop the video and try problem number 1. I expect it's going to be hard. Try it, though, because I want you to experience the hardness of doing this problem so that when I show you a way to do it, you will be motivated to do it my way, to learn my way to do it and do it. But stop the video right now and try problem number 1. Just problem number 1, not even problem number 2, just problem number 1. Stop and go. Okay, I assume you've taken the time to try this problem. I don't hope you found it hard to do. Maybe you didn't find it hard to do. But any of you who found this a hard problem to do, you pay attention right now. And you learn to do the problem the way I'm going to show you, okay? Students always ask me, Mr. Nortillo, I don't know how to do this problem. What do I do? I've told you I get that question asked of me a lot, right? And my response is, well, I know what they're asking of me. They're asking of me, like, do I multiply these things? Do I add these things? I only see one number in here. Like, what would I even multiply and divide? They're in such a hurry to add, subtract, and multiply and divide things, and they only see one number in the problem that they have no idea how to get started. And that's because getting started does not involve adding, subtracting, multiplying, or dividing. A word problem like this is best translated into an algebraic equation. That's the first thing that you do. You translate into algebra. Okay? And the easiest thing to translate in all these word problems is the word is. You can do that, can't you? What word or symbol or term do we have in algebra that is equivalent to the English word is? Equals, right? So I always look for the word is first in these word problems. and I immediately translate it to equals. And then everything on one side of the is should go on one side of the equals. Everything on the other side should go on the other side of the equals. Okay? Oh, wait a minute. How do we translate these phrases? Let's back up to the box. I didn't say anything about the box. Did you try filling in the box? Let's look at this together. If an angle is 5 degrees, then that angle's complement is 85 degrees, right? Because complementary angles have to add up to 90. So 90 minus 5 is 85. And if an angle is 30 degrees, then wouldn't its complement be 60 because 90 minus 30 is 60? Okay, what if we're calling an angle x degrees? What would its complement be? Why am I not hearing anybody give any answers? I mean, didn't we just say how to do these two problems? 90 minus 5 is 85. 90 minus 30 is 60. When you're in algebra class and the algebra teacher asks you, what's 90 minus x? You don't stare at her with a blank face anymore or stare at him with a blank expression anymore. Don't you say it's 90 minus x? That's what you learned to do in algebra, right? And same thing with supplements. Supplementary angles have to add up to 180. If an angle is 5, 180 minus 5 is 175. 180 minus 30 is 150. What's 180 minus x? It's 180 minus x. Okay? All right. So this word problem involves three things that we don't know. We don't know the angles measure. We don't know the angle's supplementary measure, and we don't know its complementary measure. But we have algebraic expressions that we might be able to use for all of those phrases in this word problem that will help us solve the problem. And the first phrase is an angle's supplement. Okay? I want to translate that phrase into an algebraic expression, and here is the expression that we could use. If we're going to think of an angle in this problem as x degrees, which would be a good idea because we have no idea how big the angle is, let's call the supplement 180 minus x. Okay? So I'm thinking of the mystery angle in this problem as x degrees, and therefore that mystery angle's supplement must be 180 minus x. I've just translated more English into algebra. Okay? How do we translate the number 5? 5. How do we translate times? Times. How do we translate this phrase? Its complement. Bam, right here. 90 minus x. There's only one thing missing in this equation now. What is it? Anybody know? There, I heard somebody say parentheses. Yeah, because otherwise you won't, 5 has to be multiplied by all of this, right? If you don't put parentheses down, you probably won't distribute and you're going to get the answer wrong. So, in a lot of students' minds, we haven't done anything yet because we haven't done any adding, subtracting, multiplying, or dividing. But what we have done here is the only way to get started on this problem. Translate the English into algebra. The rest of this problem is so easy. Algebra now tells you what to do the whole rest of the way, right? Distribute the 5. 450 minus 5x is 180 minus x. Add 5x to both sides. You'll get plus 4x over here. Subtract the 180 from both sides. You'll get 270 over there. Divide both sides by 4, and you'll get 67.5 degrees for the angle. Is a decimal number a problem? No! Angles can be decimal numbers of degrees, okay? But finally, before you move on to the next problem, check to make sure that you actually answered the question. The question says, find the measure of the angle. Am I using x in this work to stand for the measure of the angle? Yes, I am. So therefore, this is the answer to the question. But what if I had changed the question to say, find the measure of the angle's complement? All right, well, we wouldn't be done with the question then. What we have here is the measure of the angle. If I've asked you to find the measure of the angle's complement, you would have to subtract that 67.5 from 90 to get the answer to the question that I asked. So please double check and make sure you're answering the question that I asked. On the homework, I think in most of the questions, I'm just asking for the measure of the angle, but be careful because there's probably a question on the homework where you got to read it carefully and it might ask you to find the complement of the angle or the supplement of the angle. Let's move on to number 2. I'm going to work through this more quickly now and do the same thing. Translate. Look for the is first. Translate it to equals. An angle. Translate that to just a simple x. 18 becomes an 18. More than becomes a plus. 2 times becomes a 2 times. Its complement becomes 90 minus x. Okay? And the rest of this problem is so easy. I mean, once you get the hang of translating English to algebra, even that becomes easy. Right? All right, distribute the 2, and we get 180 minus 2x. Add 2x to both sides, and you get 3x on the left. Combine these, you get 198. Divide both sides by 3, and you get x equals 66 degrees. Is that the answer to the question? What did I ask? The measure of the angle. Yeah, that's what x stands for, the measure of the angle. Okay? So, wrapping up, anytime you see the phrase, its complement or the complement of the angle, you have to have learned by now that you got to translate that phrase into 90 minus x. Anytime you read one of these words problems and you come across the phrase an angle's supplement or the supplement of the angle, you have to have learned by now that you got to translate that phrase into 180 minus x. The phrase an angle, just all by itself, with no supplement, no complement, just translates to an x. And all the other translating is super duper easy. Okay? Use this method. It's a guaranteed, reliable method of solving these kinds of problems, one that I can explain to you and that we can find a mistake in easily if you make a mistake, right? If you just read a problem, you don't write an equation, you start scribbling numbers down all over the place, like some of you do, there's no way am I going to be able to follow your work and help you figure out what went wrong. Okay? Do it my way. Good luck with the homework.